Do you think we will see LLM written code that is submitted to you as a pull request?
I'm convinced it's going to happen, yes. It may well be happening already, maybe on a smaller scale.
Typically say artificial intelligence is autocorrect on steroids, because all a large language model does is it predicts what's the most likely next word that you're going to use, and then it extrapolates from there.
The release of ChatGPT by OpenAI in December 2022 has garnered significant attention, sparking curiosity not only in artificial intelligence, but also in the underlying technologies that power the AI chatbot. These technologies, known as large language models, LLMs, have the remarkable ability to generate text across a vast array of topics, making them a true innovation with no precedent in the past. Subscribe to our channel for more amazing videos on AI tools and technologies. Understanding LLMs is crucial for grasping how ChatGPT operates. These models excel at producing human-like text in almost any language, including coding languages, showcasing their versatility and innovation. This video aims to delve into what these models are, how they are developed, and how they function, to the extent that our current understanding allows. Interestingly, our understanding of why they work is still somewhat incomplete. Number 1. A large language model is a type of neural network. A neural network is a type of machine learning model based on a number of small mathematical functions called neurons. Like the neurons in a human brain, they are the lowest level of computation. Each neuron is a simple mathematical function that calculates an output based on some input. The power of the neural network, however, comes from the connections between the neurons. Each neuron is connected to some of its peers, and the strength of each connection is quantified through a numerical weight. They determine the degree to which the output of one neuron will be taken into account as an input to a following neuron. A neural network could be very small. For example, a basic one could have 6 neurons with a total of 8 connections between them. However, a neural network could also be very large, as is the case of the LLMs. These may have millions of neurons with many hundreds of billions of connections between them, with each connection having its own weight. Number 2. An LLM uses a transformer architecture. We already know that an LLM is a type of neural network. More specifically, LLMs use a particular neural network architecture called a transformer, which is designed to process and generate data in sequence, like text. An architecture in this context describes how the neurons are connected to one another. All neural networks group their neurons into a number of different layers. If there are many layers, the network is described as being deep, which is where the term deep learning comes from. In a very simple neural network architecture, each neuron may be connected to every neuron in the layer above it. In others, a neuron may only be connected to some other neurons that are near it in a grid. The latter is the case in what are called convolutional neural networks, CNN. CNNs have formed the foundation of modern image recognition over the past decade. The fact that the CNN is structured in a grid, like the pixels in an image, is no coincidence. In fact, it is an important reason for why that architecture works well for image data. A transformer, however, is somewhat different. Developed in 2017 by researchers at Google, a transformer is based on the idea of attention, whereby certain neurons are more strongly connected or pay more attention to other neurons in a sequence. Since text is read in and read out in a sequence, one word after the other, with different parts of a sentence referring to or modifying others, such as an adjective that modifies the noun but not the verb, it is also no coincidence that an architecture that is built to work in sequence, with different strengths of connection between different parts of that sequence, should work well on text-based data. Number 3. An LLM builds itself. In its simplest terms, a model is a computer program. It is a set of instructions that perform various calculations on its input data and provides an output. What is particular about a machine learning or AI model, however, is that rather than writing those instructions explicitly, The human programmers instead write a set of instructions, an algorithm, that then reviews large volumes of existing data to define the model itself. As such, the human programmers do not build the model, they build the algorithm that builds the model. In the case of an LLM, this means that the programmers define the architecture for the model and the rules by which it will be built. But they do not create the neurons or the weights between the neurons. That is done in a process called training, during which the model, following the instructions of the algorithm, defines those variables itself. In the case of an LLM, the data that is reviewed is text. In some cases, it may be more specialized or more generic. In the largest models, the objective is to provide the model with as much grammatical text as possible to learn from. Over the process of training, which may consume many millions of dollars worth of cloud computing resources, the model reviews this text and attempts to produce text of its own. Initially, the output is gibberish, but through a massive process of trial and error, and by continually comparing its output to its input, the quality of the output gradually improves. The text becomes more intelligible. Given enough time, enough computing resources, and enough training data, the model learns to produce text that, to the human reader, is indistinguishable from text written by a human. In some cases, human readers may provide feedback in a sort of reward model, telling it when its text reads well, or when it doesn't. This is called reinforcement learning from human feedback, or RLHF. The model takes this into account and continuously improves itself based on that feedback. Number 4. An LLM predicts which word should follow the previous. A reductive description of LLMs that has emerged is that they simply predict the next word in a sequence. This is true, but it ignores the fact that this simple process can mean tools like ChatGPT generate remarkably high-quality text. It is just as easy to say that the model is simply doing math, which is also true, but not very useful in helping us to understand how the model works or in appreciating its power. The result of the training process described above is a neural network with hundreds of billions of connections between the millions of neurons, each defined by the model itself. The largest models represent a large volume of data, perhaps several hundred gigabytes, just to store all of the weights. Each of the weights and each of the neurons is a mathematical formula that must be calculated for each word, or, in some cases, a part of a word that is provided to the model for its input, and for each word, or part of a word, that it generates as its output. Number 5. LLMs produce text that sounds right, but cannot guarantee that it is right. ChatGPT can provide no guarantee that its output is right, only that it sounds right. Its responses are not looked up in its memory. They are generated on the fly based on those 175 billion weights described earlier. This is not a shortcoming specific to ChatGPT, but of the current state of all LLMs. Their skill is not in recalling facts. The simplest databases do that perfectly well. Their strength is, instead, in generating text that reads like human-written text and that, well, sounds right. In many cases, the text that sounds right will also actually be right, but not always. Number 6. Is GPT-4 an LLM? On March 14, 2023, OpenAI released GPT-4, the latest version of its models in the GPT family. In addition to generating higher quality text compared to GPT 3.5, GPT-4 introduces the ability to recognize images. However, that functionality, if it exists, is not yet available. The ability to handle input and output data of different types, text and images, means that GPT-4 is multimodal. In conclusion, the release of ChatGPT by OpenAI has sparked immense curiosity about large language models, LLMs, and their role in shaping artificial intelligence. These LLMs, like ChatGPT, possess an incredible ability to generate human-like text across a wide range of topics, representing a groundbreaking innovation in the field. Understanding LLMs is crucial for grasping how ChatGPT and similar AI systems function. These models excel at producing natural language, showcasing their versatility and ingenuity. Through this exploration, we've delved into the core concepts behind LLMs, including their neural network architecture and self-building mechanism. As LLMs continue to evolve, with advancements like GPT for introducing new capabilities, the possibilities for artificial intelligence are expanding rapidly. However, it's important to remember that while these models can produce convincing text, they may not always be accurate. Subscribe to my channel for more amazing AI content and stay updated on the latest developments in artificial intelligence. Join our community of enthusiasts and learners as we explore the fascinating world of AI together.